Okay, this problem says a manufacturer knows that their items have a normally distributed lifespan with a mean of 15 and a standard deviation of 1.6. So as soon as I see the word normal, I draw a bell. Right down the middle is the mean and the standard deviation is 1.6. They then ask the 7% of items with the shortest lifespan will last less than how many years? What the heck are they talking about? Well, I think they want to know the number of years, you don't know what this is, where 7% are less than. So 7% converted to a decimal is 0.07. So they want to know what's the number of years where 7% will be less than. How the heck are we going to do that? Well, I see this thing, this normal distribution. I know that I can probably use that table that we've been using, the standard normal z distribution. So we probably want to convert to z's. So, okay, we're going to do z's. So right down the middle, z is 0. We don't know what this z is, but we know that to the left of it is 0.07. Okay, for area. So what do we have to do? This is kind of the opposite of what we had a z and we looked up an area or a probability. Now they're giving you the area, they're giving you the probability, and you got to find the z. So you kind of got to use the table in a different way. So first of all, you know that because this is to the left of z equals 0, this is going to be a negative z-score. So you want to go to your negative z-score side of the table, right? We have the area, we have the probability. You don't want to look up 0.7 z because no, we're looking for the z. We have the area, we have the probability. We're looking for 0.07 in the body because that's the area. So what you got to do is you got to look through all these numbers and find the closest thing that you can to 0.07. It's not usually not exactly. You're not going to find an exact 0.07. So you want to look for the closest thing to 0.07. So I'm looking. And if you guys look, if you look down at negative 1.4, I see a 0.708 and a 0.0708 and a 0.0694. So those are 0.07 is in between those two. Which one is it a little bit closer to? It's a little bit closer to 0.0694. So what z corresponds to 0.0694? You go across, it's negative 1.48. So negative 1.48. So you went to your negative table, you looked for the closest thing to 0.07 in the body, and you got the z that corresponded to it. So now we have a z of negative 1.48. But that's not a number of years, right? Z equals negative 1. We want to find the x. We want to find what number of years corresponds to a z of negative 1.48. So same thing, guys. You just go back to your old standard formula for z. This time you know the z. We did a problem like this before. Don't know the x. That's what we're looking for. The mean is 15. The standard deviation is 1.6. So it's an algebra problem now. So if you cross multiply, you do negative 1.48 times 1.6, you get negative 2.368 equals x minus 15. Don't forget the negative on that negative 2.368. Add 15 to both sides to get x by itself, right? So basically on your calculator, you're doing 15 minus 2.368, and you get x, I think I tell you to round it to one decimal point, 12.6. Right, so this is very different than before because this time they gave you the area. You had to find the z that correspond to that area, and then you had to convert it over to a real value in x. In this case, it was number of years. So we're still using the table, but we were looking in the body of the table this time, right, for that 0.07, because it was a probability, it was an area that they gave us. Okay, I hope that helps. Just reach out for help whenever you need it.